Hello. So yeah, it's been a very long time since I have uh, made something. So I mean, I've completely forgot to do this, but yeah, here I am doing this again. I've been practicing some of the deep learning. I'm studying deep learning right now, and I'm currently doing a project on face recognition, like looking for the papers and studying stuff. So yeah, on the other side, I have also been trying to do something like uh, deep faking audio. So yeah, it's already been done. Yeah, I know. I want to learn it, so I'm just reading stuff. So before that, I have to understand how audio works. So I tried to do something that's related to audio, and also I've been studying RNNs right now. So yeah, I have uh, you know, took both of those into consideration and looked for a paper. And I got a 2015 paper. Yeah, I know it's pretty, you know, old, but yeah, I've been trying that. And yeah, I studied the paper. The paper is listen, attendance, spell. Yeah, I've been trying to implement the paper. I have started implementing the paper. Uh, and yeah, that's that. Let me just show you the paper first, and then we will go in deep and go into implementation. Uh, I think it's not a, you know, if you want to learn exactly what to do, I don't think, yeah, you should be watching this video. But if you want to know how others implement, I think you might want to watch it, because I'm not very well experienced for you to learn the free, learn from me. But if you want to know how I tried to implement it in my starting days, I think these are the starting days of my very long deep learning uh, journey. So yeah, you can just continue watching it as whatever. Let me just first show the paper, and then okay. So to be brief, uh, there are two parts in this paper. One is a decoder and the other is encoder. I mean, one is called the encoder in this is called listener, because it's the one that takes in the audio and gives out a d-dimensional vector which could be used. Yeah, first of all, this what it does is it takes in the audio, and yeah, it does the captioning part. Okay, so yeah, so uh, we have got the model here. As you can see, this is a bidirectional long short term memory model. So to reduce the input size, we pass it, we use something like a pyramidal structure. As they have mentioned in this paper, you can just read it up. It's normal bidirectional long short term memory, like yeah, it's the same model. So first of all, uh, I have to first study about the bidirectional long short term, the implementation of it, uh, and then I will do the pyramidal stuff. Okay. For my reference, I am going to GitHub and keeping a code, you know, which I can look up to. Like this. Okay, so yeah, as I was saying, we are supposed to first create bidirectional long short-term memory. So we will first look into the implementation of bidirectional long short-term memory and then the pyramidal structure, whatever it is called. So yeah, let me just let me just get into the bi di. I'm sorry. Yeah, let's see. Okay. Uh, there are two LSTMs. One goes from one side, the other one from the other side, and then we concatenate both of them. Right? Yeah, that's what's happening. Alright. Do we are these the same cells? Like, do these have the same weights or are they different? That's what I want to know. Okay. Okay. So I think I understand that. First, let me see what this is. Yeah, I kind of understand it. So we need a LSTM cell to do that. Where I think I have an LSTM cell here. Where I'll use the same LSTM cell. I don't think I'm definitely in my head. Underscore LSTM cell, right? Yeah, I think that should be fine. And It is the forward is yeah, that should be fine. And I think it should take something like input and a hidden forward state, hidden CF, that's HP and CP after now, yeah. And okay, that works fine, right? And it should output HF, CF, HP, and this. Yeah, I think that's the bidirectional part, and we want a pyramidal. It's just take the input, right? No. I think there's a problem here. Right? Yeah, I think there is a problem. Let's see. I think I shouldn't be having this. Let us just do that here. Let's say, yeah, let's do that. I will turn off the mic now because I want to hear some music. So let me just first finish it and then I will start the recording again. Alright, so I just placed the encoder part. So I just show the code of the encoder and then I will stop the recording. Yeah, there it is. So we, according to the according to the research paper, we had something like a bidirectional long-short memory in pyramidal structure, which is like you reduce the number of dimensions by two by merging the neighboring outputs. So yeah, we used the code that we already had in the decoder. So we use the same LSTM cell that's already present in the decoder. Uh, yeah, and yeah, the bidirectional layer has two long short-term memory. Two of those. So one for the forward part and one for the backward. So we have both of them here. We look at those in the same loop. Yeah. And as for the pyramidal structure that we want, we merge the neighboring and the neighboring cells outputs. So here is that part. So then we come to the encoder part, which has three layers of pyramidal structure. So yeah, we define the layers here. So and then we just you know pass those to each of the layer and get the output, and then we merge them, and that's the final output of a decoder. So yeah, that's the basic idea of the decoder. So tomorrow we will maybe look at sequence. I mean, like counting both of these two, right? So we have the encoder now, we have the decoder now. We just need to look at the data. I think we will run our test tomorrow. So yeah, we should do that tomorrow. That's the main important part for tomorrow. So we get the data that we want, and then we will, you know, yeah, we pre-process the data, and we connect. We, I mean, define a final part where we have our encoder and the decoder is in the same model, and we define a loss function, the basic training part of the model, and then we will test our model tomorrow. So, yeah, I think that's it. I'll just yeah do this tomorrow. So yeah, that's it. Bye.